Hi, science friends. We are learning a little bit more about limiting reactants today. So, you all previewed limiting reactants in your activity yesterday, and so we're going to talk a little bit more about that today. So, when I think of limiting reactants, what I always like to think about is making hot dogs. Because when you buy hot dogs and then you buy in the package and then you buy buns in the package, they don't come in the same quantities. Usually, hot dogs come in a package of 8 and buns come in a package of 10, which makes 0 sense at all because you're going to have extra buns left over, or you're going to have to buy more hot dogs and then you're going to have hot dogs left over. And so, in making this product, the hot dog with the bun, you are always going to have an excess or a limiting factor, a reagent. So, sometimes you'll see it called reagents or reactants. Sorry, I was kind of behind on my slides there. Reagent or reactant, that's the same thing if you see it written the other way. Those terms are interchangeable. But an excess reagent is one that's not completely used up in the reaction, and a limiting reagent is something that you run out of in the reaction. So in a chemical reaction, in chemistry, oftentimes you're given so many grams or so many moles of one of your reactants, and you just have to see how much product you can produce with that reactant. And you're not always sometimes sometimes one reactant is going to limit you and one reactant you're going to have excess of generally. And so we do some calculations to help identify which is the excess and which is the limiting reagents here. So we have two practices that we're going to do together, and then I'm going to turn you loose to do two on your own, and then you can check your answers with me. So let's go ahead and dive into these. Sodium chloride, so that's what we're talking about here. That is probably what our question is going to ask us about, but we'll read further to see. Can be prepared by the reaction of sodium metal with chlorine gas. And so we see that in our equation, sodium metal and chlorine gas makes sodium chloride. Suppose that 6.7 moles of sodium reacts with 3.2 moles of chlorine. What is the limiting reagent and how many moles of sodium chloride are produced? What we have to do here every time you do a limiting reagent calculation is basically you have to set up two problems. I want to always start with what they've given me. But the problem here is that they've given me two quantities. They've given me 6.7 moles of this reactant and 3.2 moles of this reactant. And we want to know which one's going to run out first when we're trying to make sodium chloride. So I'm going to first set up my 6.7 moles of Na. Okay? Now, the question is asking me how many moles, so we're just going to keep it in moles. We don't have to go to grams or anything else here because it's just asking us about moles. So if we look at our mole ratio, we have 2 moles of sodium. So I'm going to write 2 moles of sodium so that I can cross out those moles of sodium here. Is going to make 2 moles of NaCl. That's what we're trying to find out. NaCl is what it's asking us about. Our product is what we're always trying to get to in a limiting reactant calculation. Okay, and so you may also see that those 2's are going to cancel out. So 6.7 moles of Na is actually going to also produce 6.7 moles of NaCl. Okay, so that deals with the first number that we are given. Let's look at this second number that we're given, though. 3.2 moles of Cl2. Okay? If I look at my mole ratio, we want to put moles of Cl2 on the bottom so we can get rid of it. And there's 1. There's no coefficient there, so I've got 1 mole of Cl2. And it makes 2 moles of NaCl. Okay, we can cross that out, and it's going to leave us with 6.4 moles of NaCl. Okay? So we can look at both of our answers here. The sodium, which is what we started with here, we ran out after 6.7 moles of NaCl. The chlorine, with which we started on this problem, we ran out at 6.4 moles of NaCl. So which of those limits us as to how much NaCl can be produced? Which one is the limiting reagent? You should say it's the chlorine. The chlorine is the limiting reagent because we run out of chlorine first. It gives us fewer moles. 6.4 is smaller than 6.7. Okay, so chlorine is our limiting reagent. So in this chemical reaction, if we start with these quantities, 6.7 moles of sodium and 3.2 moles of chlorine, we are only going to be able to make 6.4 moles of sodium chloride. Okay, that's how many moles will be produced because we run out of the sodium. I'm sorry, because we run out of the chlorine. Because we run out of the chlorine. I said that backwards, I apologize. Okay, so that is a limiting reagent calculation. Okay, let's do one more. So it says when a yellow powdery substance known as sulfur is combined with a copper metal, so we've got here copper and sulfur combining, a black crystal, copper 1 sulfide, is formed. Okay? What is the limiting reagent when 80 grams of copper reacts with 25 grams of sulfur? Okay? So I'm going to work up here at the top right now. And I'm going to start with what they've given me, 80 grams of copper. And also on this side, we'll do 25 grams of sulfur. Remember, we have to set up two problems, essentially, okay? And we're trying to find our limiting reagent. Now, this one, in the last one, we were given moles. And so we only had one step because we could go straight to our mole-to-mole ratio here. But in this one, where we're given grams, we have to get from grams to moles first before we can do our mole-to-mole ratio. So we're going to do grams of copper in 1 mole, and we'll find that by looking at the periodic table. So it's about 63.5 grams of copper in 1 mole of copper. And then we can do our mole-to-mole ratio. So in my equation, I have 2 moles of copper. Sorry, I thought I'd have a little more space. And we're wanting to know about this copper sulfide. Gives us 1 mole of copper sulfide. Okay? Again, make sure that you have set this up right, that everything crosses out accordingly, like it should. And so when I solve this, 80 divided by 2 divided by 63.5. And I get 0.63 moles of Cu2S copper sulfide. Okay, so that's my first answer. That's how much copper sulfide can be made with 80 grams of copper, assuming you have plenty of sulfur. Okay, now let's talk about our sulfur. If we have 25 grams of sulfur, how much can we make? So we've got to look at the molar mass of sulfur. 32 grams of sulfur in 1 mole of sulfur. Then we're going to do our mole-to-mole ratio. 1 mole of sulfur makes 1 mole of copper sulfide. Okay, there's no coefficients there, so that makes it a 1-to-1. All right, so when we put this, we'll make sure everything cancels out so we know we've set it up right. So 25 divided by 32 is 0.78 moles of copper sulfide. Okay, so which one here is our limiting reagent? You should say it's the copper because it makes the limiting or the smaller amount. So the copper is our limiting reagent. It's only going to give us 0.63 moles compared with the 0.78 moles if we have that much sulfur to work with. Okay? Now, the second part of the question says, what is the maximum number of grams of copper sulfide that can be formed? Okay, so this is asking for grams. In our problem here, we did moles, okay? You could have gone ahead and calculated grams, but I hadn't read along down here to the next step yet to know grams. So all I can do then is I can look at my limiting reagent, 0.63 moles of copper 2 sulfide, and in 1 mole of copper 2 sulfide, there are, I'm going to have to add up the grams here, 63.4 times 2 plus 32. So there are 158.8 grams, okay? All I'm doing here is just converting from moles to grams. You've done that since like Unit 2, a really long time now. This should be a simple second step that you've got here, okay? We just worked with the limiting reagent to find it. And so when I multiply that out, I got 100.04 grams of copper sulfide. That's how much can be formed. And we had to calculate that from our limiting reagent, which was copper. Okay? So as you do your next two you-try-it problems that you have to work on, I want to point out one thing. So these equations that we just did in both of the practice were synthesis equations. They only had one product, okay? But sometimes you may have a double displacement or a single displacement or a decomposition, another type of reaction where you have two products, okay? So you have to be very certain that you're calculating for the right product. And that will tell you either in the question, in the stem at the beginning, like this one said, sodium chloride can be prepared. So that is going to hint us that we're looking for sodium chloride. Or down here in one of the two sub-questions, it will tell you what you're actually looking for. But make sure you're calculating to the right reactant, okay? Because it's not necessarily the same for both products. I'm sorry, make sure you're calculating to the right product, not the reactant, because it's not necessarily the same for both products. The limiting reagent for one product could be different than for another product, okay? So you all pause me here. You all try those two problems, and then we'll go over them here in just a moment together. All right, hopefully you were able to work this without any problem. So the limiting reagent here was oxygen, okay? The equation for the complete combustion of ethane. So we had to set up two equations, two problems, one with 2.7 moles of ethene, one with 6.3 moles of oxygen. So I did that here and here, okay? These I could just go straight to the mole-to-mole ratio because it didn't ask me for grams or anything like that. I got 5.4 moles and 4.2 moles. So the 4.2 moles of water was the smaller number, and that was produced by oxygen. So oxygen was the limiting reagent. So 4.2 moles of water was all that was able to be produced. Okay, we knew we were looking for water because it told us here in this part of the question. The stem didn't give us any clues to that, but the question asked us about how many moles of water were going to be produced. Okay? Hopefully you got that one without problem. In this next one, we are looking for hydrogen gas. So these again both have two products. So hydrogen gas, it tells us, can be produced in the laboratory. And then down here it goes on to say how many grams of hydrogen. So we know we're looking for hydrogen gas. So I was a little cramped for space here. It gave us 6 grams of HCl and then 5 grams of magnesium. So I set that up here, 5 grams of magnesium and 6 grams of HCl. 5 grams of magnesium gave me 0.21 moles of hydrogen, and 6 grams of HCl gave me 0.82 moles of hydrogen, 0.082 moles of hydrogen. So that was the smaller number there, which means that the HCl was the limiting reagent. Okay? So then the question asks us, like the other one that we did, how many grams of hydrogen can be produced? And so I took this 0.082 moles of hydrogen and I just converted it to grams. And so you should have got 0.164 grams of hydrogen would be produced. So I hope you all got that. You have some limiting reagent problems to practice today. Those are in your binder, so go ahead and complete them and let me know if you have any questions on it. You all have a great day.